All right, let's record and talk about JavaScript functions. All right, so this is what this lecture is going to be. First, I'm just going to talk about some basics of functions, make sure that we're on the same page as far as vocabulary goes. I'm going to talk about arrow functions. I am not going to go into a huge amount of detail on how arrow functions behave differently because that is sort of outside of the scope of this lecture. One of the ways that arrow functions behave differently is they have a different, they work differently with this keyword, and I'm not going to be talking about that for this lecture. This keyword I'll get into in my object orientation lecture, which will probably be next week sometime. And then we'll revisit arrow functions. But for this lecture, and I just want to slaughter whoever called it this, because then if you start talking about it, you're like, it's this lecture. No, wait, it's not this lecture. Anyway. All right, so we're not going to be getting into that. I also want to talk about using functions as variables and some examples of that, or functions as values of variables. And then I want to talk about scope and the difference between var, let, and const. Scope is a really meaty subject. It's just tricky. So we'll work with it a little bit. And closures are sort of an extension of scope. So we'll talk about that as well. All right, function basics. So this is stuff you probably already know, but I just want to make sure that we're all on the same page. So what's the difference between a parameter and an argument? Yeah, Aisha? Like, for example, the A and B placeholders. Yes. You got it. Yes. So A and B here are parameters. Yeah, great, Aisha. Thank you. So for those of you following along at home, she said that parameters are the placeholders when you define the function, and that arguments are what you use when you actually invoke the function. So here, A and B are parameters, and 4 and 5 are arguments. Okay, so, right. Arguments can be variables, right? You can pass in variables. And I could, so if I wanted to, let's just, let's go into Node for a minute. And I'm gonna, oh, I hate it when you do that. You did not define my function as I wished. Okay, so now I have add, and I can say x equals 5, y equals 7, and I can do add x, y, right? Arguments can be variables. So x and y are arguments here. But then when you call the function, A represents x for the duration of the function, and B represents y for the duration of the function. Returns. All right, one thing to know is that, so returns are a way you can get data outside your function, and your function will evaluate to whatever it returns. But one thing that I wanted to emphasize is that your return statement ends the function immediately. So in this case, so we have this too many pets here, and if I give too many if I give too many pets a pet count of 600, what will it return? You have too many pets. It will return you have too many pets. Why won't it return you have too many pets and then return you have just the right number of pets? I didn't put an else here. Right. Yeah.
After a return statement, if there's not like a following function, which I just learned callbacks, if there's not a following function, it stops the process.
Yeah, so once I hit this return line, it is not going to run the rest of the function. I am not going to run this line. Yeah, nice work, Misha. I am not going to run this, you have just the right number of pets, if this has already run. So I do not need the else here. That's something that's a little subtle, but you'll see it a lot. Yeah, Brittany. It is similar to break. Break would be for a loop, whereas return is for a function. Yeah. Yeah, when I wrote this originally, I said if pet count was greater than 5, but I didn't want to offend anybody in the audience who might have had, but I figured I was probably safe with 500. So. Methods. A method is a function that is also a property of an object. So I just want to, this is more vocabulary, a method versus function. So a method is a function that is also a property of an object. All methods are functions, not all functions are methods. Yeah, Aisha. Yeah, well, no, object.keys, yeah, that's a method of the object prototype, but yes, but things like .map, .for each, .length. No, .length I think is a property. So yeah, let's actually look. So if I have, if I look at array, can I do this? No. Okay, if I say, yeah, okay, I'm not as facile in this stuff in JavaScript as I would wish to be. But so if I do r.length, that is not a method. It's not a method because it's not actually a function. Yeah, exactly, no parentheses. Yeah, but if I do r.forEach, console log, hold on, let me get this to a, for each is a method. Add is a function that is not a method. Add is not associated with any objects. And the nice thing about methods is, notice I just had to call it on my array, and it knew stuff about the array. It was able to know that the array was made up of 3 items, and it was able to console log them. So methods can access stuff about the object that they're using, and that's part of this big this that I'm teasing you about that we'll probably talk about next week.
Okay. You said not all methods are functions.
All methods are functions. Not all functions are methods.
Right, so for each is a method.
For each is a method because you need to run it on an object. But this add that I have here, that's a function that is not a method.
So I can use it on its own.
Because it is not associated with any object. Yeah, Aisha.
So is it the ability to apply the dot?
Yeah. This is a function that is also a property of this array, and you use you access the properties with that dot. Yeah.
Oh, I mean, it's just like
Yeah.
So I still come to your lectures. I'm carrying my face too. I need it.
Keep them coming.
It's okay to call a method property.
Yes, a method is also a property. Yes. All right. Other questions on methods versus functions?
Methods are
everything that were built into JavaScript?
Not necessarily. When we talk about object orientation, we're going to talk about making our own objects. And we can make our own objects and we can add methods. We can also add methods to existing JavaScript objects. Yeah.
Drug is way more complicated.
I keep hearing Justin saying, and I think it's one of, or Kelsey, because he's the male representative in the audience. Okay, so let's talk about arrow functions. All right, so basically, you can do parameters, and then the arrow, and then the function body. So here I'm defining my add function as the parameters, and then the function body. Fine. And you can make it, for one line function, there are no curly braces, and there's this implicit return. It's going to return A plus B if I don't use the curly braces. That's just arrow function syntax. And the reason that they do that is you can see just how many fewer characters this is than this here. So it's just a more compact syntax, and it's really nice when you're passing anonymous functions. So here, like, this is more readable than this one here.
Yeah.
Those are exactly the same, but one is with arrow functions and one is not. Yeah.
Just for clarity, these slides will be available to us.
Yes. Yes, exactly. Yeah. I'll put them in the phase 1 channel if you're not in the phase 1 channel anymore. Yeah. Okay. It's your last day in the channel. Okay. Yeah, Kelsey?
On the previous slide, parentheses, is there any parameters?
On the parameters, there are.
Oh, there are there, but
There weren't up above.
there were right parameters. I was just looking at the
Yes. Yes. I could change the slides here. You actually can, if there's only one, I think you can leave the parentheses off. So let's try it. Let's make a and I'm going to say num, and I'm going to return num plus 5.
So if it has no parameters, you don't have to use the braces.
If it only has one parameter, yeah, and this is just my one line implicit return that I'm doing here. You want me to try it with more than one parameter? Sorry.
So it is, because I use these, and I just found out the thing you just said earlier
About the this? Yeah.
Okay, so you're saying with no parameters, use the parentheses. With one parameter, we don't need the parentheses. And if there's more than one parameter, definitely use the parentheses.
Yes.
Okay.
But it's not wrong to use the parentheses here. It's possible that the Airbnb linter will get mad at you, but what's that? Yeah, I can't run it because I did a const, and I can't redefine a const, which we'll talk about later. But I can run this.
Wait, so I don't understand. So you can't run it because it's constant.
Oh, I couldn't, once I define, and we'll talk about this later when we talk about const, but once I define add 5 as a const, if I try and do, it's like, you've already told me that add 5 is constant and isn't going to change, so sorry, lady. Yeah.
these three scenarios,
Okay.
we will apply else.
All right. So the other thing about arrow functions is they change what this and arguments are. So those two keywords act differently for arrow functions. And there is going to be an example in the not yet written object orientation lecture. So just coming soon. But if you really want to read about it, I have a link to the MDN documentation here. Yeah.
This is 5 years. It's going to be a 6 because we have 6 changes. Is that what you're saying?
What I'm saying, no, this is for arrow functions. Arrow functions behave differently from functions that are defined using the function keyword. And so there are sort of two differences. One is that you can have this more compact syntax that you can't have with the other one. And the other is about this and arguments. And that's something I'm not going to get into now. Let's talk about functions as variables. Okay, this may look familiar from to-do list, right? So let's say I have a commands.js file and I'm requiring add and del from them. And then command is process.argv2, meaning I'm going to say node tasks and then whatever the command is. Now I'm going to do a let command func here, and we'll talk about let in just a minute. But basically, I'm just defining that command func is something that I might want to change later. I'm not giving it a value, that's okay. And now I'm doing a switch on command, and I'm saying if command is add, if what the person put in after the script is add, then I'm going to make command func add. Now this add is not the string add, right? This is the function that I imported. Or sorry, you don't say that. I required. Imported is Python. This, if command is the string delete, then my command function is going to be the function del. And as Brittany discovered last week, you cannot call this delete here. It's a reserved word and it won't work. So now command func is actually, go away. Command func is actually, it is actually a function. So I can use it. I can say, now I want to call command func, whatever it is, on the rest of the arguments. Actually, I probably want to do a join there. So this is something that it's a little strange, at least it was for me, that I am storing an actual function in a variable. And then I'm running a function depending on what that variable is assigned to. You guys have questions on this? Yeah, Kelsey? Oh, that's good. That's good. That's a sign of a great programmer if you like start to get twitchy if the punctuation is off. Good. Other questions? I need to learn how to get that thing to disappear without having to wait. What do you think, Misha?
I don't use switch cases a lot, so I
okay.
I have to say it like a statement.
Yeah, right, yeah.
That's why it's like,
Yeah.
oh, no.
Yeah.
That's what it is. It's just, I don't use switch, but I understand.
All right, scope. Yeah.
I'm sorry.
No, don't apologize. It's what we're here for.
Just wondering if you could step through what that's doing and why command would constantly work in that situation.
Oh, why const command func wouldn't work?
Yeah.
Yeah, so if I did const command func here, const doesn't let you change it later. That's sort of what a const stock and trade, right? Is that I'm not going to change it. So I can't do it out, and so I can't define it outside the switch statement. I suppose I could just say const command func add here and const command func del here, since it's not going to run both of these, and then eliminate this line. It would, yeah. If you were really committed to making it a const, that would be the way to do it. Yeah, Brittany?
So just by typing let that's all you have to do to like insert line.
Yeah.
You don't have to set it
No.
to anything.
No. I'm what I'm doing actually is I'm defining its scope there, which we'll talk about in a minute.
Yeah, you can just define its scope and then somewhere else in your coding actually define
What the variable is, yeah. Yeah, Aisha.
So I was looking at the constant in the first place on the process.rc to essentially store the slice and join after the fact and that single line.
Sure. Yeah. So Aisha is asking, I mean, so this slice and join, it's a little bit complicated and off the point. All right, how do I just want well, I think the exit is just gonna, put me back here. So, all right. Basically, and you could see that like I'm a bad person for putting text down here in the first place. So I'm just getting what I deserve. But yeah, so I could, if I wanted to, I'll just wait for that thing to go away. Go away. Okay. So I could, if I wanted to, have defined this as argument or something. But basically what I'm doing is I'm just taking everything past 2. That's what the slice 3 does. It's like from index 3 on. So this gives me an array, this process argv slice. And then I want to join that array with spaces.
I get confused between slice, split, and what's the other one? There's 3S. Right?
Oh, I'm not sure what the...
You can go process.rgb dot slice 2 and it'll take everything after.
Right, yes, that's what I'm doing here.
Okay.
Yeah. Yeah, split is done on strings, and split takes a string and makes an array. Yeah. Slice takes an array and makes an array also.
I'm still getting that.
Yeah. What would you call slice here? What new, possibly new vocabulary word would you use for slice? Slice is a method. It's a method on arrays. What about join? Join's also a method on arrays. Okay. Var, let, and const. So these are, var and let are scope. And const doesn't really define scope. It's just it can't be reassigned. So var means it's valid for the current function and any functions that might be contained in the current function. When we're talking about scope, we're talking about scope. Scope is kind of like these bubbles, and anything that is contained within that bubble will inherit the scope. Var can be reassigned. Let is valid for the current block. And the block might be a function, or it might be something like a for loop. Let may also be reassigned. And then const may not be reassigned. And const, I believe its scope is for the current function, but I actually am not positive. I don't know why you would assign const for a block, but yeah, what do you think, Aisha?
I'm not sure. I get mixed up with this one too. Is sometimes inside of a block, I will use a const, knowing that it's A, meant for that block itself, and B, that I'm not going to change it. But then also, I'm curious as to, like, in some of the work that I do, it's like, it's a choice between putting all consts in the global and not in the, and using var or let. Well, really, I don't use vars much at all, but let inside of blocks themselves and consts on the outside.
Yeah. Yeah. So, well, I mean, so in general, it is inadvisable to use globals unless they are constant. Yeah, because otherwise it's really hard to keep track of the state of the global if you're changing it and, you know, inside functions. And so, yeah, inadvisable to use globals unless they're constants. Constants are perfectly acceptable as globals. Let's see. Yeah, I just wanted to, I sort of regret not having done this while I was preparing the lecture, but let's see what the scope of const is. Creates a constant that can be global or local to the function. Okay, so it just sounds like, well, it sounds like it is, it sounds like it's like var, right? So if we look here, oh, no, constants are block scoped, like let. Okay, so they're scoped to the current block. Okay, so let's just ta-da. Okay. All right. It sounds like somebody's taking a shower. I'm not sure what's going on. Yeah. Oh, the plant's outside. Yeah. Okay. All right, let's dig into const a little bit, and then we'll dig into let a little bit. Okay, so const details. So an identifier, a const cannot be reassigned like we saw with the add 5 before. So if I say pet num is 4 and one of my pets meets an untimely demise, I can't say pet num is 3 if I've defined pet num as a const. Yeah, Aisha.
So I understood const could not be reassigned. However, it's okay to use, like, say, in the event you're having the value can change. So, like, say I was pushing into, I don't know, say I initiated an empty array. Push into, I could still use const to do that, but then, like, the value inside of that array based on my loop is allowed to change, but I wouldn't be able to actually, like, literally reassign it. Is that?
Yeah, yeah. So I think you're asking about this second part here. You can reassign elements of the identifier. So if I have pets here and it's a const, I can do pets.append. Basically, I can do anything but say pets equals. Yeah. So it's confusing because here pets is not a constant, right? But you can't do equals sign again. Yeah, you can't do equals sign again. And you can't, even without the const, right? I would not use pets as a global here, even though it's a const, because it's not like, it doesn't have a static value. Yeah.
Append JavaScript?
Append is JavaScript. What vocabulary word might you apply to it?
Method.
Oh, is it not? Is it Python? Man, okay. Push? Is that what people do in JavaScript? Yeah, okay. That was very polite. What's yeah. I had append, which is Python. That was,
I still see that. People using that as pen.
let's see.
Or, yeah.
Let's see if it works.
I was gonna say, I thought it was good, but I didn't even
Nope.
know. So we can only use a thing when it comes to routes.
Where do you store it all, honey?
That's why I have these slides so that I don't have to remember. I can just repeat. Okay. Here's a let example that I want to dig into a little bit. And I'm not sure why this is, or actually I do know why this is smaller. I used something a little bit different, but I want to make this larger because we can. Okay. So var favorite pet equals Cisco. So that is going to apply. So again, we have this sort of bubble concept. So the global scope here, in the global scope, we have Cisco. Favorite pet. So favorite pet is defined in the global scope. And then we have the function, so the global, this is global. And then we have the function new fave. And new fave now has its own favorite pet. New fave within new fave, the favorite pet has clobbered, it's overwritten the global favorite pet. But then once we're back out, the favorite pet reverts to the global. So what is that console.log going to do? It's going to be Cisco. It's going to be Cisco. So what's going to happen here is we're going to define the global favorite pet to be Cisco. Then we have new fave, and new fave has a parameter pet. And for the duration of new fave, favorite pet is going to be whatever argument you gave it. So we're going to run new fave on Mochi, and sort of inside this little interior bubble, fave pet is going to be Mochi. But when we're finished with the function and we go back out, fave pet is going to be Cisco again. Scope. Its scope is really tricky.
So how do we pull Mochi out?
How do we pull Mochi out? There are different ways, but let's for now. I want to play with this a little bit. So, actually, for this, I think I'm going to save this under presenter. For now, we'll just save it under presenter, and I'm going to call it scope. Okay. This is not, we won't worry about that right now. Okay. Do you see that? I almost just typed Python. That's the how. Okay, so if we do node scope, okay, let's okay. So now, and hold on, let me all right, so now what if let's see. Yeah, what if I really want to change? Oh wait, hold on. I want to do something else. So what if I call this, instead of fave pet, I'm going to say new favorite pet. And what's going to happen here? Undefined. Undefined because let is only in this bubble. No, in fact, it's not even undefined. It's an error. New favorite pet doesn't even exist in this scope.
So wait, when you
Ah, yeah. Okay, so I'm gonna talk about that in a minute, but let's get Brittany.
I think that's one of the things.
What if I say?
I mean, yes, because now it's outside. But would you even need to do a let? Yeah, I guess because it's scoped within the block, so you have to totally reassign it.
Yeah, I mean, remember, new fave pet wasn't defined here.
Okay.
What's gonna console log?
Right now it's gonna be. It should be.
What do you think, Celeste?
I'm not sure. It's just going to run a function, but then that function, nothing's.
New fave pet is going to be assigned to whatever this function returns. What does this function return? Nothing. It has no return statement. And it returns undefined if you don't have a return statement. So new fave pet is going to be console logged as undefined. Ah, yes. Let's put a return statement there. Now we're finally going to get Mochi.
So that, just to clarify, that will not happen if I were to wrap without reassigning the fave pet outside of the scope of the function. If I wrapped console log, new fave Mochi, wrapped in a console log on its own, it would not return the same thing?
No, that would be fine. That would be fine. So we could do this.
The proper way to write it is what you're saying, right?
No, not necessarily. I was just doing that just to use to reuse variable names and see what was going on. That's totally fine. Another thing I could do is I might say fave pet, right? I might just reuse fave pet. After all, I defined it as a var up here.
And as far as the return on the old console log, it must be there.
The return here?
Yeah, so like if you commented out that return and then went back to the console log of what is it, use fave Mochi, it's going to do that because you're being explicit, or
What do you think? What do you think is going to happen here?
I think because you're telling it exactly what to console log, it will console log, but it doesn't necessarily correct, like as far as the way it should be written.
This is saying I want to console log whatever new fave Mochi returns. What is new fave Mochi returning right now? It's undefined. Yeah. So.
Yeah, because you need to use the return tab. Like I kept trying to think that a console log is like for me to see what's happening.
Right.
And the return is the handoff to the machine. What needs to be. So the return works kind of like a console log to the computer.
Yeah, that's a great way. Yeah, great way to think about it. Console log is for you to see, and return is to be able to hand it off to another part of the program. Yeah.
like this Russia.
Yeah, right?
Okay, other questions on this? Okay, so I already started talking about scope. I really should probably change this slide and make it before all of the const let var stuff. But yeah, so it's where variables are defined and what their values are. And then we already talked about this concept of nested bubbles, where you sort of inherit scope from any functions that you are contained within. Yeah.
On that last slide, if the global was a const or another let, it would override the same way?
Yes. Yes. So here, if we had const Cisco, this all would work exactly the same way as if I had a var. Yeah. I just wouldn't be able to, without a let, I wouldn't be able to redefine it here. All right, let's have some more examples of scope. All right, so on the left, var pet count equals 4. In add pet, I'm incrementing pet count. Then, but I haven't actually called add pet yet, right? Then Fluffy made it so that my pet count is now 3. And if I do an add pet, and I console.log pet count, what am I going to get in my console.log? 4. I'm going to get 4 because here I am changing the global variable, which is something that I said don't do because it gets confusing. But that's what's happening here. So sometimes just copy just doesn't really work. I don't quite understand it. But okay, yeah, so console log, we're going to get 4. Okay, so now the one on the right is different in that I have a parameter now, and I'm working with the parameter instead of the global. So what is console log pet count going to do here? Why 3, Celeste? It doesn't actually change pet count, but pet count is the argument here.
Yeah, it's the argument.
Right. I thought pet count is the variable, but the argument I thought was
Parameter is numpets.
oh yeah.
Argument is pet count. So doesn't that mean that I'm actually changing pet count? No. I'm changing pet count sort of for the duration of this function, right? But it's not going to have any lasting effects.
So at this point, pet count is just a placeholder, but it's not going to be affected by the function.
Right. So I'm feeding pet count into the function, but pet count is not going to be changed permanently. It'll be, and it's because once I get into the function, I'm not working with pet count anymore. I'm working with numpets. Now, this is another lecture, which we'll get to sometime. Pet count, what data type is pet count? It's a number.
Right.
Not a trick question. Numbers are immutable, which means there is no way for me to change this number by like doing a dot push or by doing, there's no way for me to actually change this number. Arrays, for example, are mutable, which means if I feed an array, I can actually have lasting effects on the array if I change it within the function. That's a more complicated concept than I want to really go in here, but I do want to say that this is not universally true. It's true for this pet count because it's a number. But if it was an array, I actually can change it even if I'm accessing it as a parameter and not as a global. Yeah, it's complicated. Yeah.
Okay, so it's inside the function you would return.
Thank you.
Yeah.
That was exactly what I was thinking.
Okay, awesome. Let's do it. So, okay, so now, all right, so let's just run this just to confirm for ourselves that it's going to output 3. Fine, it output 3. Now, if I still output 3 or output something else?
It should still output 3.
Okay, how can I get it to output 4?
Address the global pet count. Return pet count.
Yeah.
You have to implement pet count.
Well, I could use the global. What if I didn't want to use globals? Because Bonnie said not to use globals when they change.
Right.
I'm returning it, which means that I can access it outside the function, right?
Right.
So what would I change to access it outside the function?
Pet count. Add that pet count to I guess you would change pet count to
Well, numpets is really only I don't want to adjust the global inside the function.
what about passing the argument?
No. What are you thinking, Kelsey?
I was thinking having just assigning so pet count equal num pet plus 1.
Inside the function?
Yeah.
But then we're altering globals inside functions, which makes me uncomfortable because it's really hard to track. Right, now that we're returning it, now we can, back in the global scope, edit pet count. Is that what you were going to say, Celeste?
Okay, I'm sorry. We're trying to return pet count.
I'm trying to actually change pet count, even though I have a parameter of numpets here, and I'm telling you that it's bad form to change a global from within a function. So we're talking about how you can actually change pet count, and the way you can do it is by rebinding it. Yeah. Because pet count is not, it's not a const.
Right, so it can't be.
Yeah. So now what's pet count going to be? 5. I put 2 of them in there. Yeah. But I just wanted to point out that you can do it many times, right? Yeah.
So pretty much if we have a variable, a global variable,
Yeah.
in order to change the global variable, we need to change it outside of, well, we need to change it outside of the function.
Yeah, exactly. You can change it inside the function. You can pass it to the function and change it inside. Just make sure you return it so that you're not having globals being changed inside functions. It's messy and bad form. Yeah. It's just really hard to track what's going on.
So best practices is to do all of your, I guess, behavior.
Yeah.
Inside the function, then store that function along with its behaviors in reassignment to the global variable that you want.
Yes. Yes.
Pull out those values from the function.
Yes. If you want your function to have lasting effects on your program, do it by returning stuff and then assigning stuff back out in the global scope. Scope is really important. And yeah, it comes up in interviews too. But it's also, I mean, even outside of interviews, just for like understanding like why code does what it does, scope is really important. Closures. You guys heard of closures?
Yes.
Do you know what they are? Okay. Say again, Bree.
It's accessible scope that goes from the current scope out to the parent scopes. Your process called garbage collection. How you access it, or before garbage collection.
Before garbage collection, but yeah. Yeah, we're not going to talk about garbage collection here, but yeah, so basically it's having inner functions be able to access the outer scope. Even after that outer scope function is no longer even running. That's this last one. It has, so basically the way you implement a closure is you define a function inside another function, and then you expose that inner function. So either you can return it, that's one way to get that inner function exposed, or you can pass that inner function to another function like a callback.
So a function with a nested function.
Yeah.
And then if I wanted to have access to that, then I would use a callback with inside of that. Isn't that messy?
Yeah, but it's sometimes what you do.
Okay.
I'll show you some examples of closures in a minute. But basically, so in order to have a closure, you have to have a function inside another function, and this is important, you have to expose it. You have to be able to access that inner function outside where it was defined. And then, yeah, the magic, the reason it's a closure is the inner function still has access to that outer scope, just even after the function has returned, which is, it's kind of weird. All right, so there are a couple examples that I want to show you. One, and we're running a little low on time, but 4 minutes, that's all closures really need. So one is this function factory. So notice that I have a function that's making an adder, and it's returning a function that takes a parameter y, and it adds whatever x was to that parameter y. So the outer scope here is x, and that's going to persist in this function that's returned. So if I do a make adder of 5, x is going to be 5, and so the function it's going to return is going to be 5 plus y. That's the function that's going to be returned. I have here a little factory that makes these adder functions. So add 5 is now a function because I'm returning a function, And if I do add 5 of 2, I'm going to get 7. It remembers that I gave the 5 here, even though this function, make adder, ran and is totally done running after this line here. But it still remembers that I gave it 5 in the function that it returns. That's the closure.
One more time for me.
I run the make adder function. The make adder's function sole purpose in life is to create another function based on a number that I gave you. So I gave it, so x was 5. So when it returned the function, it returned x plus y, but it knows that x is referring to this outer scope. That's the closure.
So where do you give it? Why?
I give it y here
When you're calling the action.
when I'm calling the function that this returned.
I see.
So it is a function. This is why it took me a while to get this.
Yeah,
And it's useful to do it this way because it allows you to use that function. Like, I might use 5, but somebody else might be able to use it for 20. It makes it
exactly. It makes it, let's say my function was more complicated than just addition, and I wanted to just have a factory that made these functions for different possible cases.
This way, anybody who's using it can fill in the x and y as they need it.
Oh, so you can see, yeah, like
Yeah, so notice now I have add 10, right? And figure it out. And so add 10 of 2 is going to return 12. Because in add 10, in add 10's scope, x is 10.
And that can exist all within one program. You can have an add 5, 10 with incrementations and then just call those variables
Over and
each
over,
time.
yeah.
They're essentially, that function is stored with that. So you have a number of functions to just call it fun throughout whenever you need them. So
Yes.
these are kind of like how we use aliases and stuff. They're quickly access. You store what you most use and create your library.
Yeah. Totally. Yeah.
Sorry, I have to.
No, this is great. I love confirmatory stuff. It's good. Did you have a question, Sabrina? Was that?
No, I was just rushing.
Okay. We do not have time to go through this private variable, but I would encourage you to read this W3 Schools example because it is actually very good. It's it'll take you about half an hour probably to go through it, but it's a really good example of using closures for private variables. Yeah.
Can I take just a few minutes and do it? I can just let maybe 2 people know we'll start a little bit later.
Sure. All right. Except Celeste. Celeste is like, forget it. I don't care about private variables. Okay. So this is another thing that you can do. Notice that I am immediately invoking this function. I make this function, and I put the function in parentheses, and then I put parentheses after it, which means that I both want to define and run this function in the same step. Sometimes you call this an IFE,
Yeah.
immediately invoked function expression, IIFE. So I'm immediately invoking it, which means that this function runs just once. And what is add? Add is whatever this function returned. Notice add is not this function. Add is whatever comes out of this function call. So I'm running this function just once. And so what that does is it initializes this counter. And remember, this counter is local to this anonymous function. But because of closures, I can access it in this function that I return.
So ordinarily you wouldn't be able to access it without closure?
Without the closure, I ran this function once and then counter is gone, right? Counter is scoped locally to this function. You run this function, it defines counter. But if I didn't have this closure, if I didn't have this function that works with counter, then there's no way for me to even access counter. It's trippy. Closures are a little trippy.
And this can you can still use the one-liner on this too, right? Where
Oh, I could use the arrow function if I wanted, yeah. So now, I'm returning this function that doesn't take any arguments, and it returns whatever counter is plus 1. Plus, it changes the state of counter. So counter, what is counter scope? Counter scope is this anonymous function and add, because add inherits counter from that anonymous function as part of the closure. Because counter is defined. Oh, but yeah, because you're setting add equal to whatever is returned, and what's returned is this function. Yeah. So counter is now a private variable to this function, that add function, but it persists. It's a private variable to any time the add function is called. Yeah, Misha?
In this case, anytime I run add the add function and not give it any type of parameter, it's still going to give me the same answer. But even if I do add a parameter in add, so let's say if I did add 5, it's still going to give me the same thing.
I'm going to go to Aisha for a minute, and I'll come back to you.
okay, so I see this in the example for closure, but could I achieve this without a closure? Could I essentially would have been, I guess, your closure version 1, where you're using like an X or whatever, X and Y to then reassign, add. I guess what I'm trying to ask is in this new one, you're passing a function to another function and telling you exactly what you want it to return based on the argument that's being passed later. So then you can change the add function as many times as you want. Is that what we're achieving here?
No. So we're actually, this is a different example in that add, and did I actually use add? No, I didn't use add exactly the same. That's good. This is a different example in that add is just a static function. Add doesn't get redefined. Add is defined only once when we run this. But because of closures, add has its own access to this counter. And that counter persists. So this add, the counter starts at 0. After this add, it's going to return 1. And after this add, it's going to return 2. And after this add, it's going to return 3. Because they are still accessing this counter.
You're not passing anything into add. It's essentially telling it's telling it what to do based on counter starting at 0 and the return of +1. So each time you call it, it just increments like.
Each time I call it, I'm incrementing this counter, which is global to the function, right? But it's scoped to this anonymous function. It's scoped to the anonymous function, not scoped to this function. If it was, I wouldn't be able to change it. It's scoped to the anonymous function, which means that I can access it outside of this function here. It's tough stuff.
Closer to the boom.
Closer to the boom, yeah.
Closer to the boom.
Yeah, Sabrina.
And you're saying because it's after the return, it's outside of it, and it can keep going in and it keep going inside and grabbing information.
What do you mean by after the return?
You set return counter plus.
Oh, yeah. Well, so this here, it's more that because this counter is outside this function that I'm returning.
Okay.
So this function that I'm returning is going to be referring to the same counter every time. This function defines the counter. And then there's like one counter over here that continues to exist even after I'm done running this anonymous function. And so here's this counter, and then this function inside gets to keep referring to that counter, even though this function is the anonymous function is run and gone.
So like starting your car, you use the battery once, and then the rest of it's on the alternate.
Yeah, kind of like that. Yeah. Yeah, Kelsey?
Is counter then kind of a property of that?
I suppose you could sort of think of it that way. The way I think of it is more, it's a global variable that only add has access to.
Counter does exist as a global variable. It's not.
Yeah, but I couldn't say console log counter down here. Because out here, I don't have access to counter. It's not globally scoped. It's only scoped to this anonymous function. Yeah.
I use this as like a security feature. Like if I didn't want, let's say I build a game and I didn't want somebody to hack in and just, increase the counter. And I put it in a private variable like this.
Yeah, absolutely. And that's one of the things, that's great, Eugene. And that's one of the things that if you go through this W3 schools, they actually start with a lot of different ways of doing this and what the problems are if you don't use a closure. And that's one way you could do it. You could just define counter as a global variable up here, right? But then, then somebody goes into their console in their browser and they're like, counter equals 18,000, right? Whereas they can't do that if you have it as a private variable. Yeah, Kelsey.
Clear. When you do the first add, when it executes, you create add.
Yeah.
It's not increasing by one. It's still 0 there.
Yeah, it's still 0 because we haven't run this function yet. When we run this anonymous function here, we haven't run the function that it's returning yet. So its counter is going to be 0 until we run the function that it returns, which we called add. Okay, I'm going to give Justin, let me see, I just have resources. There are a lot of discussions of scope and closures. There's closures on MDN. I like, this is a really detailed blog post, I think, about scope and closures. But yeah, so.
Is that link on the channel?
Yeah, so I'll make sure I post these slides both in phases 1 and 2, and I'll post the recording also. Okay.
Thanks, Bonnie.
Thank you, and thank you very much, Justin, for letting me take that time.
You're talking about some